Okay. Can they delete the this? Can someone guess it? How it's going to be? Pooja?
Yep.
Hmm?
Firstly, deletion of T
Okay. So delete T.
and add FOU,
Okay.
then deletion of AY,
V F O R. Okay. So you are saying we delete T. Okay. Then F O U we add. Then R we skip it. Then A you are adding. Is that what you are saying?
no.
Hmm?
Even deleted.
Skip R and delete AY.
Uh, yeah, that's what. I'm skipping R and okay, delete AY. Right?
Yeah.
Okay. So according to this, it is right, but which is not the case. Okay. So this is where I was about to tell you guys. Okay. So how we can do this basically, you can substitute T for F, right? So I told you one substitution. Okay. R also is a substitution. So not R is not a substitution. Let's say that. Okay, wait. Instead, I'm getting confused. But let's see. Let's go here. Okay. So we have tray and we have the matrix here. Hello.
Yes.
Yeah, Gokul.
So we have the matrix here. Okay. And the traversal. Okay. I'll just play the traversal part. Okay. Okay. So how do we write the traversal here? Navika.
So we'll start from the top left.
Mm-hmm.
Post that. How do we do? +1. Huh? Then we'll go to 3 because F and T are not matching. So it's +1 of the minimum out of 443. So we go to
Okay.
3.
Yeah.
Then O and R are not matching. So we go to 2.
Mm-hmm.
Then again 1.
Mm-hmm.
And then 0. No. Yeah. No. 4. Yeah. Sorry. R and Y. Yeah. We go to 0.
Right. Okay. Fine. So the minimum edit distance for this is okay. See, the thing is, if you are having a diagonal. Hello.
Yeah. Yes.
Okay. If you're having a diagonal, it can either point to no change or a substitute.
Okay.
Okay. Okay. So when you remember when the 2 points were same, we said that it is no change. Correct.
Yeah.
Earlier. See, when 2 and 2, then they are no change. Okay. But if you have a diagonal with an increasing difference. Okay. See, now now we have a diagonal. So this will represent the substitute. So instead of you're doing insertion or deletion, you can do 4 substitution directly. That's what the point is. In this, if you see 4 diagonals are there, right? All the diagonals. So from the previous diagonal and the current diagonal, there is a difference of 1, which means it's a substitution.
Okay.
That is the point I'm trying to say here.
Got it.
Hmm?
So, Gokul, just one question. So, like, there are 2 ways we get to know about the editing. What do you call the editing? This thing yeah, the editing. So, it's the first one is through the topmost left column, wherein the grid that is 4. That means there is a 4 editing space, and the other one is we count the hop of the diagonal, right?
Correct.
In this case.
I'm just saying what are all the operations that is happening here to get that 4.
Yeah.
Who knows? Maybe probably there could be a question on this also, right?
Okay. So there are 4 in this case.
Correct. There are 4 in this case.
So 0 to
You can
1, 1 to 2,
mhm,
2 to 3, and 3
3
to
to
4. That's how you do it?
4. Yes, and all the four are substitutions directly.
Okay, got it.
Okay, so in this case we saw that it was delete, delete, and then no changes, and then one insert,
Yes.
right? This case was great. Okay, okay. Now should we do that other one? This one? Do you guys want to do it?
No, I think like I'll do it by myself. Like Pooja, if you want to do it, we can move to the next question.
So how we got this 12 is basically now we don't need to worry. Now it's gonna be like this. See, 12 to 11, right? And then it came from here. Okay. So wait, yeah, 10 to 10. Okay. So now this didn't come from here because okay. Okay, let's you can do it by yourself. Let me move it to the next one. I don't have time also. Hmm?
Yes.
Okay. Uh, okay. Okay. So we were doing this. Pooja, did you understand this? Do you know how you done this question?
Yeah, yeah.
Okay. Can you help us here?
Yes.
I'm deleting this. All right. So we saw this, right? What the sequence, I mean, sequence does. So if you're passing in the data like 1, 2, 3, 4, we passed it earlier, right,
Yes.
Navika? And then
Yes,
we got
yes.
the output as like 4, 3, 2, 1. This is what the output was. Correct?
Yeah.
You're not aware of this, Navika?
No, no, I understood.
Okay, it was the output. So what if we pause something like 1, 2, 1, 3, uh, 4, and then I'm giving 0. Okay. So if I
Hmm.
give like this, what will the output be?
I believe it will be the opposite.
No, 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 no. That's not the case.
Reverse.
No, 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 no.
Is it in the decreasing order? Okay.
What?
432 110.
No, no. 4, 3, 2, 1, 1, 0. That's not the case. Okay. See. So here, what is the length, Navika?
4.
Hey.
Actually, in this one, oh, okay, 6.
Hmm. So what is L? L gonna look like?
5 times zeros, and the last one would be 1.
Very good. And the last one will be 1. Great. Okay. So now for I in range of n minus 2. What is n minus 2? Which is
In the
4.
range of 4.
Correct? 4 comma minus 1 comma minus 1. So it means it will start from 4 and it
3
will go
2
till 0. Yeah.
3 2
4,
1
3, 2,
0.
1, 0. Right. It will go this much. So for the first iteration, sequence of 4. If sequence of 4 less than sequence of 5, see, fourth question
Yes.
is this, right? Is 4 less than 5?
No.
No, right? So you go to the else part. Else L of I equal to 1, which means L
L of
of 4 will become 1.
Okay.
Okay. Now what you're doing? Go to the next iteration. So now I is going to be 3. Okay. So what are you doing? Third is 3 less than 4. I mean third element less than the fourth element.
Yeah.
Fine. Right. So 3 is less than 4, which is true. Then what are you doing?
1 plus L of 4.
I plus 1.
So, yeah.
Okay. So I plus 1 is 1, and this is going to be 2.
2.
Okay. So you go to the next iteration, right? So in this point, I is going to be, what is it? It is going to be 2. So you're going to compare
Yes.
this and this. If the
Mm-hmm.
previous element is less than the next element, you add 1 to the previous one. Correct?
Yes. Yes.
Okay. So then now 2 is not less than
We'll
1.
make it 1. So we'll make it
Correct.
1 and yeah.
This will make it as 1. Okay.
And then
Now
2.
what? Repeat.
Now we'll get 2, no?
Yeah,
In
this will
L
become
of
2.
0.
Very good. Yeah, very good. So and you're returning the max of L. So this is the list. And what is the max of L?
3.
3. Okay. I mean it's returning 3, which is the so the point is you will get the See this. This is the correct answer.
The function turns the length of the longest. Okay.
Got this?
Yes.
It's based on the test case. You need to take the test case properly, and if you think the first test case is coming like this, so it's a reversal, don't try to answer that. Okay, make sure you verify that with different cases also.
Okay.
Any doubts in this point?
So
Hello?
longest sequence is 134, right?
Correct.
Okay, and the length of that is being returned. Okay, got it.
Yeah. Okay. The function takes big O of n to return the output. Is it true or false?
I think it is true. True.
Only one for loop, right?
Yes.
Then
The function returns the length of the longest increasing subsequence. Even this can be true. Oh, 1 second. The algorithm uses dynamic programming. The function returns the length of the longest. Yeah, I think it is fine now. The third one also.
no.
No, it is not a subsequence. It's a sequence.
Okay, sorry. Yeah, sorry. Yeah, it's my bad. Yeah, I didn't read it as subsequence. I mean,
Okay.
it didn't hit my mind. Yeah.
Right. So what about the last option?
No, it's not. Yeah, dynamic programming.
Why dynamic programming? What is a dynamic programming?
Because in code here it is started like L equals to 0 star n minus 1.
0 star n minus 1. Okay. Okay. You are saying something here. Okay. What do you mean by that? How come this is making it dynamic programming?
We're actually making this separate array like a list as well, right? Which we initially fill with 0
Hmm.
almost. So that's actually done in DP, wherein we have the separate memory sort of a thing, and then
Is it the only thing? Hmm? Could there be any other reason? I'm just checking. Fine. I'm not able to answer that. But if you guys are okay, we'll move ahead. Guys?
yes, I think that's what we're able to make out from the question.
Mm-hmm. So you can refer that, okay, and how to find out. Basically, dynamic programming means that you don't need to do the same computation again and again and again. Okay. So in this case, so we just travel it once and we are trying to find it out. Yeah, we do store it in a different path, but yeah, this is simple dynamic programming, I think. Fine, we'll move ahead. We'll move ahead. Go ahead. Pooja, answer that.
Can be solved using the dynamic programming method. Edit distance, yes. First one is correct.
Now it's okay. First option.
Yeah, the first one is right. Just
In
reading the other one.
m plus n time, it should be mn.
MN, yeah.
Hmm.
The edit
Okay.
distance will be 0 only when the two strings are equal. Yeah, it's correct. Third one is also correct. The maximum edit distance between the two strings is equal to the length of the larger string. Yeah, it's also true.
Yes.
Correct. Hmm. What about this?
What is the length of longest common subsequence of strings?
Hmm.
D, then D, no, AB,
Hmm?
AB,
1 second. E-
So what to do before this? Should we do a matrix and do it?
C, D.
Hmm? If you say we can do this fast. Hmm?
No,
But
we
Pooja,
just
have you done
like
this?
Yeah, it's 5.
even I did this yesterday and it was 5 on a check
Oh.
and show you, but now I'm able to understand. Matlab, yeah, I'll
In
be able
in
to obviously do by grade. Pooja, how did you do it? Like, which one are you
in,
taking?
in subsequences we delete we taking sequence, but in between we can delete
Yes.
mismatching characters.
Hmm. Correct.
So you're removing D from the second one, towards the end, like the second last D, in order to make it A B A C D.
Yeah, yeah. After BA we remove this D, then add CD directly.
Okay, okay. Yeah, that's how even I did, I think. Now I forgot.
Okay. So let's just just recap how to find that. At least you just give. I'm not gonna draw anything. Okay. We're just gonna see it. Not opening. Man, there is some network problem. Ah, going back. The answer is 7. First, the answer is 7. Hello.
Yeah,
Yeah, good.
Should we try to see that how it is done?
yeah.
What is happening to my internet? After refresh, it is coming. We are looking at subsequence, right?
Yeah.
So for secret and bisect, what is the longest common subsequence?
4, no? No, one second, let me just see first.
It's basic.
Hmm.
S
4.
C T 4.
Yeah, SECT, right? Great.
4.
And how do we fill this, box? So initially we put zero zeros, always all the places zero, right? Whenever there is a match, we put one. Or how do we put it? Whenever there
Yeah.
is a match, what do we do?
Whenever there's a match, we put 1. One second, let me just check.
Is it one
No, no,
or
no,
one
no.
plus the
No,
diagonal?
it's the diagonal plus 1.
Correct, that's what. Hmm? Diagonal plus one. Here also diagonal plus one. There is a match diagonal plus one. If there is a match diagonal plus one, we get 3 here. But isn't the answer 4? Mm-mm-mm.
We did it in the question in the morning that it's 1 plus whatever we get. So we're getting 3 and 1 plus 3 that gives us 4.
No, the morning question. What do you mean by morning question?
Morning we did one MCQ sort of a thing. I don't remember that exactly, wherein we
Correct.
had that which was the correct
Uh-huh.
structure for
Correct.
LCS and yeah. So in LCS, remember we had 1 plus
Hmm.
for LCS. So I think from there we can get it that whatever we get and we need to add 1. I'm not sure whether it's the right approach or not, but
Pooja, what do you say?
No, actually, see, it's correct. In subsequences, we can drop some letters. So
Correct.
here it is S E C and then T.
Correct.
4.
SECT is what it is. Correct. And
4.
from the matrix, how will we be able to identify that? That's my question here. Looking at the matrix. So is it just 3 plus 1? Hmm?
Maybe.
Okay. So shall we try to do the what is it? Matrix quickly for that this part? Should we do
yes,
it?
yeah.
Okay. Is there a way to do that easily? try it.
Good idea.
But I need to have them all. Oh, why is this taking so much time?
I'll just quickly write this and then I'll tell you, then we just put it on the different cells.
This is local. It will take
You
me
can do
some
it
time.
on your Google Drive, no?
Yeah, that's the best, but who knows?
On a G sheet. Yeah.
This is fine, no. All right. So just tell me A,
A B C B D A B A C D
D. Wait, D A B
B
A
A
D.
C D. Yeah.
Okay, I hope this is correct.
A B C B D A
Hmm?
B A C D. Yeah.
Okay.
Hopefully.
Oh my God. Okay, fine. So I think I should put it here, right? B
Yeah. B D
B D C
C
A.
A B A D C D.
Right? Okay. Hope this is good. Okay. Then what we need to do?
First we put
Okay.
like 0 rows and 0 column, no? The
One
last
more
one.
thing we need to give extra, right? Yeah, we need to give one
Yeah.
extra. Correct. This will be 0. I think this is okay. Okay, perfect. Yeah. So next, D and D are equal. So we put 1.
1,
Then
All yeah.
0,
0. But we still have a match here, right? D and D is there. So which is 1,
Right.
0,
right? Or may I, bring it like this? This is just a one step work, okay? Just take my mouse. Give me a second, please. Hope this is fine. Okay, go ahead.
0,
Like this. Yeah. So here it is.
0,
Okay.
0, 0.
Yeah, it's 0, right? 0. Wait.
No,
What?
1, 1. It's
1.
1, then 0.
Okay. I think there is an option to highlight the cells, right?
Yeah. You can just like yeah, you can just put a table sort of thing.
Great. Okay. Fine. So I think that was done, right? So what's next
0,
for C and D? Hmm?
2,
Okay.
2.
Okay. Basically, it's 1 plus the diagonal, huh?
yeah,
Okay. Great. Then.
0,
Hmm.
0,
So are we taking the minimum of the 3?
No, no.
Then
no,
I don't
0. It's directly 0. Huh?
yeah.
If it is not match, it is a 0 directly. If it is a match, we take 1 plus the diagonal. Am I right?
yeah,
Okay. 0, 0, and then now I believe we are at C.
here 1,
1. Okay.
0, 0.
Great. So now D is 0.
0,
So
0, 0.
A
Then
it is 1.
1,
Okay.
then 0,
Again it's 1,
0, 0,
0, 0, 0. Okay. So now D and B 0.
0,
So
0,
0,
0.
0,
Here B it's 2,
2. Hmm.
then 0,
0,
0.
0,
Again 0,
0, 1.
1, then
Then 0, 0, 0,
it's
1.
1,
Hmm.
0, it's 3,
0. Here it is 3. Okay.
then 0, 0, 0.
All mismatches. Great. Okay.
Yeah,
D it is 1,
1,
0,
0,
1,
1,
0.
0, 0, 0.
Here
Here it's
1,
1,
0. Right? Okay. 0, 0, 0. For this, it is going to be 1 again. Then 0,
0,
0,
0,
0, 0,
2,
2. Just 3 more rows. Let's finish the 3 more columns. We'll finish it up fast. 0,
1,
0, 1, right? Yeah.
0, 0, 0. It's 1, 0, 0,
Okay.
0,
What's next?
0, 0, 0, 1, then 0, 1, 0, 1, 2,
Right? Great. Okay. So this doesn't what? This doesn't make it like how we thought earlier, right? Now this is it is good that we did this. Guys
Yes.
are able to see it. It is good
Hmm.
that we did that, and the answer is supposed to be 7. Either we made a mistake there or made a mistake here. Fine. Um, so how do they connect the dots?
Hmm.
Exactly, they are doing the same. Let's check this. Oh my God, we made a mistake. I think that was for sub. Um, what was it? That was for sequence. Sequence, I think. Longest common sequence. Guys,
Just, just come on the deck once again.
hmm? See this? That's what I was wondering. Okay, so what does that represent? Now let's come to the point now. What are we waiting for? This is the sequence. Subsequence can drop some letters given to things.
This is how we did this one also, no?
Yeah, this is how we did. Length of the longest common subsequence. What does the right hand side represent? And what was the base one? Bottom one. Long LCS is the longest path connecting the non-zero longest common number entries. One. I don't still understand this.
There must be a different way. Let me
A,
check it.
you can see like A, B, A, right? And then it is B,
One.
right? I mean, A, 3, 2, 1. 3 is the maximum one, right? According to this. So just A starts from here. A, B, A, right? Correct. A, B, A, and then C and B. So which is coming as 5.
A,
Hmm? See,
C.
the top bottom A, B, A, C, D. Okay. So if we come to the bottom also, what do we have? A, B, A. So if we ignore the C, then we have C, D. I mean, if you ignore this, you get my point?
Yeah. What are you doing? Like, just come again.
See, see this. A, B, A, C, D. Correct?
Yeah, yeah.
Okay. So also you have A, B, A, C, D.
Right. That is 5 now.
So is it mistake from their side? You created as a number?
No, but then we have BD also. Just come
Yeah,
on to
yeah,
that.
yeah. In starting we have BD also.
BD also, yeah, okay. So it will be 7. So it's like BD,
BD,
then
AB.
ABA, CD. And we're
Then where did
removing
you go wrong?
Yeah, it's correct. BD, then AB,
Okay.
A,
Then did
ACD.
we,
then
yeah, did
remove
we
this
make
D,
an
then remove
my
this D and the CD.
repeat? Remove?
In left side, C
Correct.
vertical position. It's BD, then remove C,
Uh-huh.
AB, A, then remove D, C, D.
Correct. So that's how I have highlighted, right? I mean, the darker ones are the sequence,
Yeah.
non-dark ones are the things. Okay. But my question is, where did we go wrong in this while doing this?
No clue.
Maybe this table for finding sequence, not for subsequence.
Okay. That's why I also asking you. So what is the common subsequence? I mean, common sequence among the two. So is it the same? Like, A, B, A, C. Oh, A, B, A is the longest common sequence, huh?
Yeah, longest common subsequence.
No, sequence. No, no, not sequence, like common word, I guess.
Subsequence, no?
Word. SEC, just if we code 3 to 1, right? SEC. SEC is the most biggest common thing. What is the
What is it?
subsequence? Subsequence is when you can drop the letters.
Okay.
So this is longest common word, we can say like that. Longest common word.
Okay. Understood. Yeah.
So yeah, that is what is happening here. Longest common word is what is happening there at that point. See, LCW.
Yes.
Exactly. Look at this.
Yeah.
This is what they are having, right? This whatever we did, it was for longest common word, and if you want to do the same for longest common subsequence, that's a different way.
Okay. Understood.
Okay, so just wanted to see that how to fill those. How do we fill those? Same 0 0, and yeah. So each element is going to be 1 plus the minimum of the minimum or maximum.
0.
1 plus the minimum. Huh? That's how they'll say something here. Longest common. How does it look like?
1 second. Just, yeah. Like
So 1 plus the minimum, I think. Yeah, it's always 1 plus the minimum. So is it always like that? Yes, it is always like that. Right.
and if it matches, then
Match is also the same.
1 plus the diagonal.
Match is also the same. Wait, it was here, I think. This one. Once, see, maximum of the right or the bottom. If it matches, it is the 1 plus diagonal. You're right.
Yeah.
Uh, Pooja, okay?
Yeah, repeat once.
Okay. See, for longest common subsequence, okay, if it matches, it is 1 plus diagonal.
Yeah.
If it doesn't matches, it is maximum of, so it was not the 1 plus, it is maximum of the right and the bottom.
Right and the bottom. Okay.
I think
Or you
that's
want to
where
try
we
it?
made the mistake, no?
Sorry?
I think that's where we made the mistake.
No, we did not make the mistake. So, yeah, I mean, we made a mistake in order to do the subsequence, but we actually did the right one for longest common word.
Okay. God.
I mean, we did the diagram, I mean, the things for the longest common word, LCW.
Longest common word. Okay.
Yeah. If it is longest common word, just, add one to the, I mean, if it is not matching, 0. If it is matching, add one to the diagonal. That's for longest common word. Okay.
And for subsequence?
For the subsequence, if it is matching, add one to the diagonal, same like previous. Okay. If it is not matching, take the maximum of the left and the bottom. I mean, the right and the bottom. See this. Look
Okay.
at this. You'll be able to understand it from here, or able to
Yes,
see
yes.
this.
Yeah, okay. No, I'm just jotting it down also in my own language.
Yeah, yeah.
Understood, yeah.
There are like 5 different techniques or something like that. Maximum, if you see, take this week, maximum 10 different points you need to remember how to do a particular step. Maximum that much.
Yes, yes.
But they are important. I mean, it may be confusing. Okay,
Yeah.
Pooja?
Yeah, yeah. It's okay.
Great. Okay, chalo. So if we do in such a way, then we'll get it as 7. I don't want to do it now. We'll move forward. So Navika, is this okay for you? This was easy one, right?
How many unique paths are available from 0 to 0 to 5, 0 to 510? Yeah, so how are we doing this? Just come on the grid once, please. As
Yeah.
in we start from here, and we just supposed to, we cannot move diagonal.
Now
We
no
can.
diagonal. Either move right or 2 steps down. No
Okay,
diagonal.
okay. Okay. Then
So how do you
yeah,
do
I'll
this?
be able to do that.
How?
We start from 0, 0, no? Like,
Yeah.
yeah, so then I don't think this is going to be an issue.
The answer is 252. How will you arrive at this?
Oh, 252. No, no, I don't know this.
Hmm?
There must be a formula for this.
Yeah. That is what I was just explaining to her. Okay. Do we have it here? Yeah, grid pass. I'll take the example here. Okay, look at this, Navika. So given this
Yes.
point 0, 0, if you want to reach 5, 10, okay. So
Yes.
any path you take, you are supposed to take exactly 1, 2, 3, 4, 5 steps right and 10 steps up. Yes or no?
Yes.
Hmm? Anyway, so if you are taking the blue line, so it's 2 step up, 2 step right, some 5 steps up, 1 step right. So total will be, you'll be taking 5 steps right and 10 steps up.
Yeah.
Any path you take. So in order to find out the number of unique paths, okay, so the formula is simple. It's total steps. How many steps? 5 steps on the right and 10 steps on the up. So what's the total? It's 15,
15. Yeah.
right? 15. Of the 15, you can choose 5 steps right or 10 steps up. So 15 choose 5 or 15 choose 10. Both are same. You
15,
understand
yeah,
what I mean? Hmm?
yeah,
Is it clear?
yeah. You just come back on the last line, please, once what you said. So, like, we have the total that is 5 plus 10, which makes it 15 steps.
Hmm. Correct, which is 15 steps. Of the 15 steps that you're totally going to take, you just choose the 10 steps where you're going to take right. Oh, sorry, up.
Yeah, and 5 towards the right.
You don't need to choose the next 5 because by default it's going to be what?
Okay. Yeah, that's going to be right. Okay.
By default, right? So you just need to choose the 5 steps where you're going right, or choose the 10 steps where you're going to go up. The remaining steps are going to be the opposite of the other.
Okay, okay.
So hence the formula, which is 15 choose 5 in this case to have the total number of uniques. So in that case, if you come to this question here, tell me how many unique paths you have? 0, 0 and 5, 10. What is the formula for this?
That's what I wanted to ask. Like, we have 15 steps in total we have to take. That's 5
Is
plus
it
10.
15 steps in total?
Yeah.
Is it so? One step right and two step down.
It's total 10 steps.
So you take one step right, two steps down, one step right, two steps down. So the two step down is calculated as a one step.
Okay.
You see? You understand it?
Yeah.
So it is going to be
Mm.
like 0, 0 and 5, 5.
Okay, yeah. Half of it. Yeah.
Half of it, exactly. So if it is half of it, so 0, 0, 5, 5, which means 10, 10, 10, 10, 10 right and 10 left, 10 bottom right.
Yes.
So which is what? 10 choose?
What's 10 choose 5? What's choose?
Mhm. So you haven't done your stats one, right?
I have not, I have not taken BS degree. I'm doing diploma only, direct diploma.
Hmm. So which means you won't have
Direct
your
diploma.
statistics.
No, no.
Pooja, come on, help her.
Yeah, say.
10 choose 5, how to calculate it?
Combination formula like NCR factorial n divided by factorial
Okay.
r into
Okay, okay.
factorial minus r.
Mm-hmm.
Do we have it here in this calculator? No, huh?
No, but I'll do it now. 10 C5, no?
Hmm. Correct.
10
Yeah.
Okay.
factorial be 5 for 4 into 5. ठीक है. Okay.
But so they're asking here complexity of the above recursive function with and without memoization. Hi guys, do you guys know about the memoization? Navika? Pooja?
I read a little, yeah, I'm like,
Pooja? What about you?
I'm behind.
I forget it.
Hey, memoization is nothing. Just keeping in memory what we have already done.
Yeah,
Okay.
yeah, yeah,
And
yeah.
I highly recommend you guys to watch the previous discussions. Okay, it's there. See, total of 4 hours we have discussed this week 9. It was really good. We have learned a lot there. But if you have time
Okay.
on it,
It's the link which you have sent on WhatsApp.
yeah, you have I have a playlist over there wherein all the pdsa videos are uploaded.
Okay.
Check in that same YouTube.
Okay.
Yeah. So what will be the asymptotic complexity for the above recursive function without and with memoization? So what is this doing here? How will we find this out?
I think without memoization would be, just scroll down.
You want to see the complexities? What is
Yeah.
it? Nothing. Why do you want to see the complexity?
Because that's the only way I'll be able to get, I'll be able to
Okay,
land on an answer.
fine.
But you tell me if you have, obviously you must be having a better way.
But I want you guys to check that video for that.
Okay.
Okay.
The
because
problem is that I don't know. No, we don't I don't have that much
much
of
time, huh?
time wherein I can watch. I really want to watch, to be honest, 4 hours time. Sorry.
Okay. See, for that I need to explain you what is the memoization also, right? So why do we need the memoization? Fibonacci of 7. So what is
Yeah,
Fibonacci of?
I saw this on the video, service
Yeah.
video. Like we have when we do Fibonacci of 7, so we have 6 and 5, right?
Hmm.
And then for 6 we have 5 and 4. So we make this recursive tree, and we
Correct.
see that we're repeating on certain numbers
Yeah.
about which we already know the answer. So we save that answer in a different array altogether, like a list, and then so that we don't have to do it again, compute it
Basically, it's
again
not
when
it's
we
a
need it.
dictionary. Okay. It's
Yeah, yeah,
not an array. It's a dictionary.
yeah. I was just C plus plus
Yeah.
have that
Correct.
background now. Yeah.
All right. So, so how what is this? Okay. Pooja, you recall something on that?
Yeah. Got it.
Okay. Okay. Now, what is this doing here? N sum. I don't know what is n sum. So let's read the question. So the number n is to be created by adding the elements of a list of positive integers L of length m. So we have a list of positive integers of length m. That is something which I can understand. What is this? N is to be created. Okay. So do you understand the question here? Because
Yeah, yeah. The number n is to be created by adding the
so,
elements of
so
list.
let's say like 1, 2, 3, 4, 5, 6, 7. I have some list of positive integers, okay? And I'm asking, so n sum, give me a sum of the numbers, so that the sum is going to be 15, and I'm passing the list. You get the point here? Hello?
Yeah, yeah, yeah.
I want to get 15 and return the list. I am passing the list and the sum that I want. Okay. If n
Okay.
equal to 0, it's a list of empty list.
Yes.
Okay. If n is less than 0, return none.
Hmm.
So because the list is a some list of positive integers, right? It can never decrease. Hello.
Yes,
Yeah.
yes.
Okay. Great. So what is this doing? So for I in L, x equal to n sum of
We're
n minus.
removing we're removing the first element like recursively
Hmm.
from the list till the time it becomes, if x is not equals to 1.
So I think what we are doing here is basically, yeah, we are removing the list and recursively you are doing n sum of, next is going to be 15 comma
Two,
the same list, I think, huh?
2, 3, 4, yeah. No, it's good.
Not 2, 3,
Sorry,
4.
yeah.
Array,
Yeah, sorry, yeah. My bad, yeah.
the same list.
14, yeah.
Correct. So if x is not equal to none, uh, okay, then I think we don't even go to this point, right? So x, we are still going inside of our inner loop. It will go for n sum, you know, 13 comma L.
Well, then 12.
Yeah, exactly. 12 comma L, blah blah blah. So many things it will go, and then finally will come as n sum equal to 1 comma L. Okay. So if x is not equal to none, are we returning? Okay, wait. Exactly. So finally, this also is done. Then we'll get n sum of 0 comma L, right? At a particular point. Girls, I mean, Pooja, hey, can
Yeah.
I call you guys girls or should I call you as women?
I think girls would do. We are not
Girls
like
would do,
I'm
right?
not that old, just 22, huh? So not a woman.
Don't tell the age, okay?
Are you so? Oh goodness, we're in 21st century, Gokul.
Okay, come on, come on. Let's come back here.
Yeah.
So at a particular point, we'll get to a point 0 comma L, right? So see if n is equal to 0, we are returning the whole list. I mean, so we are returning the empty list, correct?
Yes.
At this point, it will come out of the iteration, and it says that if x is not equal to none, you return this, but x is none, right? At this point, is it right? Is X none? Are we storing it? Confusing. Okay, wait. X is not none. X is an empty list. Is empty list equal to none? Hello?
No.
No. Yes or no? Mm-mm-mm-mm. Hello? I'm confused here. I can't do it here. Python file. Okay. So I'm going to put X equal to none. Y equal to empty list. Um, X. Let me make it as Y not equal to none. Okay. So this will give me whether it is a true or false. Uh, okay. Fine. Let me save it somewhere. If I run this, see it's saying true. X is not equal to none. Okay, which means if we are returning an empty list, it is not none. Okay. Hello,
Yeah.
Navika.
Yes. Yeah, yeah.
We just confirmed it.
Yeah.
Mhm. Fine. So since it is not equal to none, we are returning X plus X is an empty list, right? Plus I. I is going to be what? One in this case, right? Because every time we are taking I in L, I in L, I in L, the first element in L. You understand,
Yeah.
Navika?
Yeah, Gokul, understood.
Okay. So if you're understanding this, then every time it's gonna be a list of one, 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 everything like this, right? So you'll get 15. So if we do the
It will
memoization,
be,
huh?
it will be one, one, one. Why it's going to be one? Like, shouldn't be one, two, three, and so on.
1, 2, 3. That's what if we are not changing it here, right? Are we removing the list? That's my question.
No, no. What I'm saying is, you're saying it's going to be one, one, one 15 times,
Yeah,
but it's a
correct.
for loop, right? So it's going to be one, two, three.
Why
Don't you
two?
think?
Why two? Why are you saying it is going to be two?
I thought it's going to be iron range of um the length of the list. So okay,
No.
anyways, yeah.
Fine. Let's. I'm confused with this. You guys try to answer this question, okay? Hello.
Okay.
Hmm? Try to answer that. I'm not sure exactly.
Yeah, Gokul, yeah.
I'm not able to answer at this point. It's already late. Okay.
That's fine. Which question number is this? Question
That
number
was
seven,
question
no?
number 7.
Okay.
Okay. Hey, if you find an answer, please send it in WhatsApp. Hmm?
Yeah.
Okay, great. So what about this question? Have the largest contiguous sum of 15. What are the indexes structures to find the largest contiguous sum? How do we answer this?
Max of L of final m plus 1. Max of L plus 1.
Okay, this is interesting, right? We'll take the answers also. So the first option is correct.
Even I
Okay.
think these two. Yeah.
Sorry?
No, no, even I was just thinking that the first one should be right.
Yeah, the first and second one are correct. So which means third and fourth are wrong. Why is
Yeah.
first and second correct? Current element and the previous element is going to be the maximum. So where I is equal to 1, 2, 3 up to n minus 1. Hey, these both are the same.
I mean, Google, like, was this like these questions weren't taught in depth in the videos, no?
No, we don't have enough time to do all those things, right?
No, no, like in the video, like the one which they provide us in the portal,
Correct. That's what I'm
weekly
saying.
content. So it was,
Yeah.
yeah.
What do you mean?
No, I mean like these all things weren't covered in depth over there. Like in the for the initial weeks they had covered it, so it was easy, for week 1 to week 5 or 6. But
Hmm?
then gradually week 8 and week 9, like that's what I feel. Not able to
That's
get that much of content in terms of the graded assignment. It's
hmm.
fine in terms of coding, but when it comes to MCQs, then that's an issue.
So probably they want us to explore more by ourselves, just like how they do in
Yeah,
IITM.
yeah,
There is no particular syllabus. There is no particular class. All the thing you need to do is go and listen to the lectures or something. I'm not sure. Okay, let's come back here. So how do we get this? Okay, see this. I and I minus 1. I is starting from 1 at this point, correct? Yep.
Yeah.
Okay. Here the length equal to n. You're starting from I. You're going till n minus 1. Right? I starts from, they are saying that starting from 1. Okay. That's the first one. And second option says that I starts from 0 and it goes to n minus 2. See? Are you able to see this?
Yeah.
Hmm? So if you are starting from 1, they are saying that I comma L of I minus 1. So here if you are starting from 0, it's just the same again, right? It's a maximum, min or max. So you can say it like reduce, uh, what? I think we can just add 1 to this. Max of I plus 1 and I. Are you able to link these two? Hello? I think I'm confusing
Yeah. Yes.
here. Did I confuse you guys?
no, not as such. I mean,
See, these both are same. I'm saying that these both are same. What I'm saying is that the first option is saying that max of L of I, okay, and L of I minus 1, the current and the previous one, okay. We are starting from the index 1.
yeah, yeah,
We are starting from index 1, current and the previous one, okay. We are starting from index 0, current and the next one, right? For the index 0, you don't have a previous. It will say index out of range.
what do you think?
Yeah. Yeah.
You found out. You got that point, right?
Yeah, yeah. And even the second one, like I got it because we're starting from n minus 2. So it's
Hmm.
like the
Correct.
current in the next one. Yeah.
Yes. Okay. Hope it's
Yeah.
clear for the first option. Okay, they are one and the same. So why is this option wrong? So max sum I comma j. Okay. So
This doesn't make sense.
exactly that doesn't make sense.
Yeah.
I don't know. Like, can we even write like this?
Yeah,
I
that's
comma
what
j.
even just seeing at that at the first sight, I just kind of
So are
excluded
they
it
say
from
are they saying something like max sum starting? No, I don't know. I don't know. So probably we can not write like this, or what should we do
yeah,
for this? They don't even give provide us with the solutions.
right. So just exclude it. Like we can just quickly
Correct.
move on to the next one now.
Puja, okay.
Yeah.
So we just have two questions left. What is the minimum size of the table to find the largest contiguous sum of the list of integers of length n? Size of the table.
Minimum size of the table. I
Ah, so
the first
they
one.
are Sorry, the first one, no?
Yeah, seems to be, I think.
Why? Wait, I'm not sure.
No. One row and column, second one.
Why? Why? That's the question here. Largest contiguous sum in a list of integers. Okay, so it's like one row and okay. So basically, this is what the formula they have given, right? Hmm? Okay. So let's take this array for example, Navika. Hmm? So the
Yeah.
largest contiguous sum of, okay. So they are saying
Okay,
that
okay, okay, okay. Yeah. Okay.
this is the
Hmm.
sum. Go ahead, tell what do you want.
No, no, I understood. I understood. Like, I don't know that that's obviously not going to be the right explanation, but that's what I was able to make out. That
But
like given
how
this.
one row and n columns? How? So I think it is going to be. Let's use this formula, now. Let's use this formula, whatever they are given. So max sum is an array, okay? An array of how many elements do we have at the top? 1, 2, 3, 4, 5, 10 now. 1,
10. Yep.
2, 3, 4, 5, 6, 7, 8, and a 9. Okay. So I believe we have 10 empty spaces. So max of, so for the ith position, right? So current and the next. So max of these two. What is max of these two? It is 0, right? Max of these two is 2. I don't know. I'm just taking this. You guys let me know if it is going wrong. So I did a max of these two. Now I'm doing max of these two. Again 5 is going to be 5. Max of 5 and 9 is again 5. Max of this and this is going to be 7. Max of this and this is going to be 8. 8. And that's all. Right. We are not taking this.
Okay, yeah. So yeah. Understood.
Okay. Now we need to get the
Mm.
maximum sum as 15. Now how do we get that
Mm.
point?
7 plus
So
2.
how do we get that 15?
Shouldn't it be 16?
They are saying that it is 15. Look at this. Why 15?
I was just taking the sum of the last two ones. Like, I don't know.
So you took the sum of these two.
Yeah. Mm.
Okay, okay. Is it something like, see? So if you're having a repetition, okay, Navika, if you have a
Yeah.
repetition, if you have a repetition, that means there are three numbers. Okay, of the three numbers, okay, that number is the biggest one. See, this previous number. So for in case of this 5, see, 3 and 5. So 5 is the biggest one, correct?
Yes.
Okay, in case of 5 and minus 9, 5 is the biggest.
Yeah.
So whenever you have, you know, this kind of a junction,
Got it. Yeah.
it means that it is
The other two numbers are less than the one. Like,
correct. So they
neighbors
are
are less.
discontinuous.
Yes. Okay.
Okay. So wherever you see an increase, okay, that is where the continuity comes in, I think.
Yeah.
Okay.
Yeah.
So if you have two and two continuously coming, so which means it's not the case. You can skip these two. Okay. Maybe you can remove the second one. Okay. So now see, these are continuous. You can say that these are continuous and these are continuous, right? So shall we similarly take a different example and check it out? Hmm?
I think we can like you want to do it or we can do it by ourselves later on.
No. Just one question alone we'll do it. Okay? Give me some numbers. 9, 8, 4, -1, -2, 10, 20, 30. Is that fine? So the longest, biggest consecutive, sum is going to be what? It is 16 this at this point, correct? I'm just trying
Yes.
to do it. Okay, I'm just trying to do it. Let's see. The maximum of these two is 9. Again 8.
8,
Then again
4,
4. Okay.
-1,
Yeah, this is going to be -1. Okay.
10,
10,
20, 30,
30.
20. Yeah.
So how do we take it?
10 plus 20 plus 30, no? 60.
Correct. Fine. Okay, let's skip this. We have got. You can check it out.
Yeah, sure. Think we
But seems like one row is enough sufficient in order to
yeah,
find
yeah,
it out.
yeah. Yes,
That's
yes.
the piece we can say. We don't need to create a matrix. Asymptotic complexity for the problem using the correct inductive
Order
structure
of
in
n,
question.
yeah. Yeah, that's pretty much it.
That's it. Okay. Fine.
Yes.
Okay. We'll go for
What is
consecutive.
it?
No, the same problem. I'm just
Gokul, just a question. Like, you are having a class at 7, no?
correct. Even now 6.
Even at 6? Like,
Yeah, I
oh,
have to now.
so you're not taking a break also, okay.
No, I don't.
So now, what will you do?
Sorry.
What will you do right now? Which week?
That's all. I have a different session, different subject. Oh, in the evening 7 o'clock. You're
Okay.
asking me.
No, I'm talking. Yeah.
That
PDSA. Yeah, you're taking the session of PDSA today at 7.
correct. We are doing week 11. Week 11 or 10. I think it was 10. We are continuing with where we left.
Okay.
Hello?
So like, aren't we doing? Yeah, Gokul, I'm here. I'm saying, aren't we doing graded assignments of the previous weeks? Any of them, week 7 or
Let me stop the
something of
recording
that
here.
sort?